Welcome friends, this is yet another session of PySpark again. So we will be trying to do some machine language, that is linear regression. Actually there is a lot of different ways of doing the same thing when using linear regression. Post-processing and pre-processing, everything you can do differently. But I have tried to use SQL more. Okay, so some of you may be thinking why it is different from other things. There is we have been doing all these things for so much time, and all these features are available in SQL also. That is why I am using SQL for a lot of things. So this is one of the ways of doing things. People may or may not like that. It's up to them. It gives us a lot of flexibility for doing things while using SQL. That's my point. Okay, so let's start the session. Again, here also we will be using VS Code. Okay, we'll be using VS Code and also Jupyter notebooks. So let's start. This time we will be using a CSV file. Okay, this is the CSV file. It is having age, name, age, experience, gender, department. What we will try to do is we will try to predict the salary. Okay, this is what we will be trying to do, and we will also try to do some post-process and pre-process adjustments. The post-process adjustment will be doing something related to adjusting the inflation rate, and the pre-process adjustment also we will be doing. So this is how we will be using all these things, importing all these things. So in some cases vector assembler, line regression, you will be using all the standard things. You have to import all these things, that is a Spark session, vector assembler, linear regression, regression evaluator, vector to array, and column. These are the things that we are using. And so let's start from that. We are using the Spark session to build a Spark session. Getter creates using, then we will get the Spark session, and we will be loading data from the earlier file that we have shown. Spark read.csv, header is true, as you can see, info schema also true. So this will be actually giving us a schema. Okay, so this is actually some computations. Otherwise also you can do that using SQL. Department wise average salary we are calculating, and also filtering the data for 25, but we are not using that anywhere. Okay, gender wise employee count also we are taking. Everything, as you can see, what we see here is we actually read the data from CSV and converted it into Spark data frame, and then we will apply group by department and aggregate on salary average, so that you get the average salary for a particular department. I hope you understand. It's almost same as saying select AVG salary from what is that, employees, or what a salary or whatever table, and group by department. This is what is the meaning. Same thing actually when it comes to filtering data. You can see this is where filter you will be using. If you are using SQL, you will be using where filter, data.filter data of age less than 25. See, it is almost same as saying where age less than 25, age greater than 25, sorry, is greater than 25, age greater than 25. And again, department wise employee count, it is also grouped by gender and count. Same thing happens in select also, it is grouped by count of gender. Next, we will be creating a employee view on the data frame that we created, and so that it is available for the SQL session. As you can see, we are having department row number. Actually, we are trying to create a department. Okay, department and department ID. You can actually, there are certain easily available things for doing this. If you want, you can do employee using SQL, or if you want, you can use the ML things. I mean, functions are there. So again, we are using from the department, we create the department view, and again we are using select department ID. That is why we are using this, is we are doing some pre-processing here, because the regression actually can use only integer values, integer or float double values, okay, number values. That is what. So here what you can see is we are using department ID, experience, age. These three things we are selecting. I mean, we are using inside vector assembler. So these three things must be in number variable, number values. That's why I use that. Output is features. So we will be transforming department ID, experience and age into features array or vector. So this is everything. Actually, as you can see, these are all available inside the employee table and department table. We are joining it. And using it. Okay. As you can see, the join is on employee view E, join department view D on department D dot department and E dot department. So both of them are having department name. We create a, as I told just now, I mentioned that we are creating a vector assembler. That's why we had did the pre-processing of giving department ID. So each department will have a department ID only like 1, 2, 3, 4. You can see that when we will be printing. Data transformed. That is, then what we do is we will be using this assembler to transform the data. It is having a transform method, and we pass the data and we get it transformed in this particular manner. You can see the print schema. I given the print schema so that you can see that what is happening. Then we will create a training data. We actually select features and salary. This we will be using throughout. Okay, this is the data that we will be using throughout. So data transform we use throughout, and from that data we actually randomly split. Actually, we have to create a training data and test data. It is always better to use a small portion of the whole data as a test data that will be using for prediction. And here this basically all ML is basically data only, I mean big data only. So don't get confused. Then we will be actually bringing more things on that. So we are splitting it. Earlier I told you this type of assignment is possible. Okay, so this is giving returning two values. and it is individually assigned. Training data and test data we are getting on a random split of 0.8 and 0.2. It is 80% data belongs to training data and 20% belong to test data. We give a seed 1040. We can give any number and a number there. No issues. Again, from that we are creating a linear regression using features column. Label column we will be using salary, and prediction column we will be using predicted salary. In the test data also we will be using the same thing, and we create a model from that, lr.fit training data. This is for training. Okay, everything is having a summary. You can individually print all the details, or like that. Again, we have a test data. Earlier I told you we are having test data. Test data also we are displaying. Then we come to predictions. Again, the train predictions. We are having training data. Earlier we created here training data, right? This is the training data. From this training data we create train predictions. This is actually used for testing purpose. I mean later, not for generating predictions, but for testing purpose of the generation. That is the prediction what we create. That here you can see the regression evaluator on the here itself. That's what we are using for testing or evaluation purpose. It is evaluating whether what we did is correct. Okay. There is actually multiple ways of doing the same thing. Here we are using train data for train predictions and test data for predictions. That's a normal way. Regression evaluation again we are doing on salary prediction column, predicted salary, and RMSE. RMSE is root mean square error. Okay. From that actually we will be evaluating train RMSE. I mean again train RMSE, so that we can see the difference. Okay, you can see in the bottom you can see here root mean square error is there for RMSE as well as train RMSE. That is predictions as well as train predictions. This is the two things available here. You can see that all the messages are given clearly. Only test data and train data is there. Similarly, we will be evaluating for another one, that is R square on test data and training data. So the model coefficients that we will enable us to understand it better, whatever it is happening. Model coefficients and model intercept actually give us much more idea about what is happening. So from this we will be printing all the transform data from columns 0 to 3. Actually, this is all to analyze the coefficients. Okay, higher weights will be having impact on target values, and higher weights, so you have to sort it accordingly. Largest first, that's on the descending. That is why we have given here reverse equal to true. Here we had given column 0 to 3, and a map will be done on absolute value of coefficients. Everything will be here, the values, the values and everything will be shown here. So you see here, feature importance is having feature and importance, so this is assigned to the feature and importance, and we print it, format and print all these details. Again, it will be very interesting going. What we do is, with column, actually features is, I told you, features is an array. Okay, so actually it is a vector. From vector we will actually convert it to an array, not an array, sorry, earlier we converted it to vector, and now we are converting it to an array. And from, again we create a temporary view, predictions. Earlier we had created two temporary views, that is EMB and department, and from here what we do is we create a prediction, that is salary for a particular age. You can see earlier we had shown that department, experience and age. Okay, based on all the three parameters we are creating a prediction for salary. Also, if you come here, we are using this one, predictions table, and you can see all these values are, I mean, once you can, the predictions have been generated, and we added a column features. So in using this, we will be splitting here. We can be, what we are doing is we are splitting the array, that is p dot feature array, the FETIRR of 0 is a department ID, FETIRR of 1 is experience, FETIRR of age is 2 is age. These are the things we have given. The previous salary is here, the predicted salary is here, predicted salary adjustment also we have given as adjusted salary here. So 0.043 is the inflation rate that we have given. We are giving inflation rate on the top of predictions, and again joining by department ID and other things, order by department ID and department ID, then experience and age. These are the three things we are sorting. Then we are showing all the details, results here. So this actually contains the pre-processing, post-processing step also. That is, we are splitting the array and displaying the result as columns, as well as what we do, we adjust the salary, predicted salary based on the inflation. So let us run this code now. Yeah. So this is the schema. Here we have given department ID, experience, age, all experience, everything is integer here. Department ID, experience, age, everything is integer. salary is integer, gender and department also is there. So coming down, you can see this is the vector, features vector is there. Okay, features vector is what? Department ID. One is department ID, 6 is experience, 31 is age. These are the three things, and you get a salary of 75,000. This is the root mean square error we have printed. Coming down, actually you will need lot of data to get all these things corrected. ML is actually based on data. I mean, if you have a lot of data, everything will be right. I mean, a lot of correct data you have right things. Otherwise, it will not be that much correct. If you give, if you can give, here we have given to around I think how many lines we have given? 193 lines we have. If you want, you can add more. Again, see, this is what we are talking about. This is the weight applied to department ID, that is 2876.15, and actually it is not a bad weightage. I mean, given everything is almost right, because experience should be given priority over the age. That is 100% so. Everything is correct only. These are all data. That is average salary, like that. Average salary, average count, female count is there, 96. Then this is the adjusted data. That is, we had created an adjustment above inflation. If you want only, you can do that. But normally what happens is, every year they will be adding a inflation value. I mean, whatever, maybe 2%, 3%, something like that. Additional add every time they will be adding. Now what we given is, we are given 1.43% over predicted salary. You can see here, the earlier salary was 75,000. The new salary is, predicted salary is, 77,000. It's almost 2,000 more. On the top of that, we added 1.043, not 1.43, 1.043. That gives around how much is that? Around $600 increase. See, it is actually similar. Okay, engineering 6. Okay, you can see both of them are same. Here both of them are same. Here earlier we had given two things we had given, that is 75 and 76, but now it is adjusted itself to 80,373 for both. That's a nice feature. And coming down, you can see other things are there. I mean, in engineering, what happens is, your salary will be lesser than what you get in Yeah, you can see that 10,000 for finance, and it got to 92,000, and age is 35. Okay, it is actually based on, if you want, you can even drop the age. If you think that age should not be mandatory and only experience should be considered, then you can actually drop the age, okay, from this features, because it brings an additional complexity there. This is the data that I am talking about. These two things, that is, here it was 85,000 and here it was 90,000 earlier. Now what happened is, the predicted salary was 86,000, 88,000 and 88,000. The reason for that is, you can see here a guy with 9 years of experience and 36 age is given 90,000 already, and here it is given as 88,000. I mean, there's some, I mean, normally all departments have certain performance and other things, so you can already find what actually has gone through. So the normally what happens is, finance departments usually get more higher salary if you even have the same experience and age. Here engineering is having higher salary, a bit higher salary. Yeah. Yeah, this is all about data analysis here. I hope you understand how we created that 1.43%, that is, or not 1.43%, which is actually 0.043. So it comes around point, yeah, point 0.43. Yeah, its inflation is 0.043, and we gave it as 1 plus 1.043 into the predicted value. That is what preprocessing, and also the split array. This is all things that we want to discuss at this point. And please keep watching. See, if you look here, you can understand there is one is having 75. Okay, 6 years 75, 76. This is the original salary that we are having. Okay, then 2 1033 is 85,000. 1033 is 85,000. Coming down here to 85,000. Yeah, actually what we have corrected, we have done a good correction, I think. If you want, you can add that inflation. I mean, this is just an example to show you pre and post processing, and also other things. I mean, how to use the linear regression to generate a what is that, a prediction. Thanks all for watching. Please continue watching, liking, sharing, commenting, and also subscribing. What I would say is, if you like this, if you go through this, please like it. I mean, it is also very important. If you like it, only people will know that you are being watching, and that will be actually a boost to our morale. Okay, thank you.